Alright, I'm gonna mute myself.
Okay, Madni channel begin. Bismillah.
Okay, Bismillahirrahmanirrahim. So in this video, we are going to talk about different types of tests that are performed to identify carbohydrates. So the first test in this series is basically a very fundamental test whether a solution, an unknown solution, contains carbohydrates to begin with or not. And for that, we perform what's called a malicious test, MOLISCH apostrophe S test. A malicious test basically tests for the presence of carbohydrate. And the way it works is that we add hydrosulfuric acid, which dehydrates the solution, and it would lead to a compound as a reaction with hexoses. So the result is that excess hydrochloric acid is going to gather at the bottom of the test tube and will leave a purple ring on top of the fluid. And the presence of that purple ring is an indication that some type of carbohydrates are present in that solution. So, uh, so important thing to remember: what does malicious test for? It tests for the presence of carbohydrates. If the test is negative, we're done. We do not need to conduct any more tests because carbohydrates are absent from that solution. If, however, the test is positive, that purple ring that I talked about, we would move on to the next test to identify whether this solution contains polysaccharides or not. So a polysaccharide test would be iodine test. So iodine test tests for polysaccharides. So we would add a few drops of iodine to the test tube. That would if the solution changes color, that means that polysaccharides are present, and we would do what's called a color test, a CT test. So, for example, if the solution turned blue, that means that it is starch. If the solution became purple, that indicates the presence of dextrin. And if the solution turned reddish, that is the presence of glycogen. So these are polysaccharides that can be tested through iodine test, and that's what it tests for. Now, you already knew that carbohydrates exist in the solution, and if the change of color does not happen, but the malicious test already told you that there are carbohydrates present, so that would mean that this was a negative iodine test. That means that it contains either monosaccharides or disaccharides in the form of reducing or non-reducing sugars. So the next test that is performed is another important test that is called a Benedict's test. A Benedict's test basically tests for reducing sugars. It tests for sugars that have 6 plus carbons present in them. So Benedict's test is not a test for non-reducing sugars. It is a test for reducing sugars. So that is an important thing to remember. Now, of course, if the reducing sugars are not present, that would by default mean that the solution contains non-reducing sugars. So if you add Benedict's reagent to the solution, and the solution turns rustic red or orange, that would indicate that 6 plus sugars are present in that solution and that the reducing sugar test is positive. Now, if it is positive, it could contain monosaccharides such as glucose and fructose, or it could contain disaccharides, for example, maltose and lactose. So glucose would be example of a monosaccharide. Fructose would be another example. For disaccharides, example would be maltose and lactose. If the test was negative, no, so if the test is positive for reducing sugar, we're not done. We have to do a few more tests. However, let's talk about the negative Benedict's test. If the test was negative, that means that the solution contains non-reducing disaccharides. Ahmed, give me an example of a non-reducing disaccharide.
Sucrose.
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 Okay.
Yes. Su- Sucrose is table sugar. So if you know that your solution contains table sugar, and by the way, this is also a color test, it would turn thymol blue. That would indicate that sucrose is present. You're done. You do not need to conduct any more tests.
Can I add on?
Your Sorry, say that again.
Can I add on?
Sure.
So just to check if your solution has non-reducing sugars, that is sucrose in this case, we're gonna add HCl as well. So that I guess that's what I remember. HCl डाल के we're gonna see that is sucrose present, or yeah, is a non-reducing sugar is present. So that's it.
Sure. Yeah, but according to the scheme that we have to do in the lab, uh, we are done at this point. Of course, you can continue to go on.
It's not
I'm
mentioned in
sure.
the scheme, but I remember from the class we had, the
Mhm.
professor did mention this. So I thought
I
it would be, uh, it would be good if I did add this point on.
Yeah, yeah, absolutely. So HCl test can be done to further verify that sucrose is definitely present. Um, so although the thymol blue test would also indicate as a result of the Benedict test that sucrose are present. Now, let's go. So at that point, you would stop. You do not need to conduct any further testing according to the scheme that we are given in this course. However, if the test was positive, that indicated monosaccharides or disaccharide present. Monosaccharides would be glucose and fructose. Disaccharides would be maltose and lactose. Now we move on to finding out whether uh, whether this has monosaccharides, right? So Benedict test would be positive regardless if it's monosaccharides or disaccharides. So we need to further break it down. Does the solution contain monosaccharides? So we're going to conduct a test called Barfoed test, Barfoed, Barfoed test. So Barfoed test tests for the presence of monosaccharides. If the test is negative, that by default means that the solution contains disaccharides. So, but the test itself, Barfoed test itself, is to check the presence of monosaccharides. And the way it works is when we put that Barfoed solution, if within 3 minutes, in less than 3 minutes, Barfoed test turns positive, meaning there's a change of color, that means that monosaccharides are present. If it's been more than 3 minutes and the color has not changed, or the color changes after 3 minutes, that would indicate that the solution contains disaccharides. So if there are disaccharides, we would use a color test to figure out exactly which disaccharides they are. There is another test that can be performed. It's called Asazone test, OSAZONE, Asazane, excuse me, Asazone test. So different colors would indicate whether they are, which exactly which um, disaccharide they might be. Going back to a positive Barfoed test, so let's say within 3 minutes, uh, Barfoed test became positive. That means that monosaccharides are present. Now we have to test whether the solution contains ketose monosaccharide or aldose. So, so we would conduct a test called a Sylvanoff's test. A Sylvanoff's test, if within 30 seconds becomes positive, that means that the solution contains ketose sugar. Example of a ketose sugar would be a fructose. If within 30 seconds the color did not change, that means the solution contains aldo sugar. An example of that would be a glucose. A keto
Glucose.
sugar example would be a fructose. So just to recap, we start with a malicious test. A negative malicious test means there's no carbohydrate. Positive malicious test means carbohydrates are present. If carbohydrates are present, we do an iodine test to check for the polysaccharide presence. If the test is positive, the solution contains polysaccharides, and the color blue, purple, and reddish color would indicate whether they have starch, dextrin, or glycogen in that order. If the test is negative, that means the solution contains monosaccharides or disaccharides. Then the third test would be the Benedict's test, and a negative Benedict's test would mean that that the solution contains non-reducing disaccharides, for example, sucrose, indicated as thymol blue test. There may be other tests that could be performed, as Avid had mentioned, for example, one with HCl. However, that is not given on this scheme that we are following in this course. A positive Benedict's test would indicate that the solution contains reducing sugars. Those reducing sugars could be of two types: monosaccharides and disaccharides. Monosaccharides are glucose and fructose. Disaccharide example would be maltose and lactose. We would move on to Barfoot test to see whether the solution has monosaccharides. If the test is positive within 3 minutes, then that indicates the presence of monosaccharides. If the test is negative or it takes more than 3 minutes for the color to change, then that means that the solution contains reducing disaccharides. Going back to the positive side, if the test was positive, Barfoot test was positive, then we would move on to conduct a Sylvanoff's test, which basically tests for keto sugar. Positive would be keto sugar, and a negative Sylvanoff test would be an aldose sugar. Okay, are you guys ready for a question answer session?
Yes,
Of
sir.
course. Should I record it separately or keep
No, no,
in
no.
this one?
Keep going. Keep going. What does iodine test for?
Whether it's a polysaccharide or not.
Exactly, the presence of polysaccharide. So iodine tests for polysaccharides. If the iodine test is negative, then by default we know that the solution contains monosaccharides or disaccharides. Okay, but the iodine test actually just tests for polysaccharides. Now, Benedict's test, what does it test for?
Reducing and non-reducing sugars.
Just the reducing sugar, right? So if the test does not become positive, then by default we know that it is non-reducing sugar. Okay, the test would be for reducing. So I could have asked the same question in another way. Give me a test that I could conduct to figure out whether the solution has reducing sugar. What would be the answer?
Benedict's test, right?
Benedict's test.
Right. Okay. What test could I conduct to definitively find out whether the solution has monosaccharides?
Barfoot's test.
Barfoot test. So if the Barfoot test is positive, we know that it has monosaccharides. If the Barfoot test is negative, then by default we know that it has disaccharides, reducing disaccharides. Okay. Okay. So which test would tell us that a solution contains keto sugars?
Sylvanov.
Sylvanov.
Sylvanoff test. Give me an example of an aldose
Glucose.
reducing monosaccharide. Aldose reducing monosaccharide.
Glucose.
Glucose. Okay, awesome. That would be it.
Okay. Well, that's a wrap. Alhamdulillah. Whoever's watching. Naveed Bhai, do the outro.
Do what?
The
Ouch.
outro.
Outroll.
Yep.
I don't know how to do that. You do that.
Subscribe, guys, if this was helpful. Let's have
And
it.
I ain't doing that. You guys do it.
Like, just don't sound that desperate. Yeah, just do the formalities.
You guys do it.
Ahmed is gonna do it.
No.
Ahmed, Ahmed,
Okay.
why not just add a small outro at the end rather than us telling us to subscribe. And why not just add a bell icon or a subscription, Jeff, during the whole lecture? Won't that be good?
कल वाइवा है मेरा भाई एडिटिंग करने बैठ गया
Again, time for that nonsense.
That was so spontaneous, Ahmed. Kal bye bye mera bhi.
Okay. Well, that's
Okay,
a
no
wrap for
no
the
outro
recording.
needed.
Yeah. Assalamu